calculate the values of those expressions using x equals 10. Let us start. Let us start. Let us start. Amukelani, are you there? Have you started writing? Amukelani? Can you hear me?
Yes, sir.
All right. I hope that you are working out the first one there. The first expression, 200 minus 5x. All that I want you to do is to substitute x, the value of x being 10, just in the expression there, and then find or evaluate the value of the expression in A, just the one in A. Right, well, few hands. Amukelan, do you want to carry on maybe with A? Or are you still busy?
Yes, I'm still busy, sir.
Okay.
Hello.
Yes,
Hello.
right. Let's go to now the user.
Can you hear me, sir?
I see user, yes. I can hear you.
I substituted 10 in the place of x, sir.
Yes.
And I simplified. Are we simplifying, sir?
Yes,
So
you
basically simplifying it. I got the answer is 150, sir.
150.
Yes, sir.
How did you get 150?
200 minus 5 multiplied by 10. Multiplied by 10.
Okay.
Or we can just say 10 multiplied by 5.
Okay. 10 multiplied by 5.
Minus 1. I mean minus 200.
Minus 200.
Yes,
okay, so basically you said 5 times 10. 5 times 10 gives you 50.
50, yes, sir.
Then you subtracted 50 from 200.
Yes, sir.
Get 150. Yes, that's correct. All that you need to do is to substitute the value of 10 here, which is the value of x, which is 10. And this will give you 5 times 10, which is 50. And of course, 200 minus 50 gives you 150 there.
Yes,
so
sir.
basically, you are correct. That will be the answer there for the first one. 200 minus 50 to get now 150. So thank you very much indeed for taking the time to answer that one. Can we proceed to the next one?
Yes, sir.
Let's go to another participant. I think we can now go to, let's go to Charlton. Charlton, can you answer the second one, the B?
So what I did was I said 5 multiplied by 10, sir, because the value of 10 is, the value of x is 10. So then it gave me 50, and I passed it by 40. Then my answer is 90, sir.
So 5 multiplied by 10 is 50.
Yeah. Then I got 90.
Plus 40 gave you 90.
Yes, sir.
Yes, that's correct. So that should be the correct value there. The 90 is the correct one. 5x plus 40 and 5 times 10 is 50. 50 plus 40 is 90. So yes, I fully agree with you there. That will be 90 is our final value there. And of course, we are proceeding with the C.
I don't know, it's this one. I don't know, it's this one.
There's a hand already. Amy. Amy, can you go to C? All right, it looks like this. Amy, are you there? Right, we seem to have a challenge with Amy. Can we go back to user again?
Yes, sir. Can you hear me, sir?
Yes, I can hear you.
So I simplified the brackets first, sir. The ones in the brackets, sir.
Okay,
And
so we're talking about
and
C.
yes, sir. Simplify the
Okay.
ones in the brackets, sir. And of course, the answer is 195, sir. 195, sir. And multiply it by 10, sir. Then I multiply it by 10, sir.
Because you multiplied 195 by 10.
Yes, sir.
How did you get the 195?
I subtracted 5 from 200, sir.
Okay.
And I got 195, sir.
Yes,
And
so
I
195 multiplied by 10.
10. It's 1,950, sir.
1,950.
Yes, sir.
Yes, I fully agree with you. That is the third one there. Or rather C, that is S. Now we've got 200 minus 5, which is 195, and then thereafter you multiply 195 by 10.
These are the same things as
Yes, sir.
1,950. So basically, what you have done, and I fully agree with you. That's the third one there, which is C. So that is also correct. Thank you very
Yes,
much.
sir.
Let's carry on with the fourth one.
Can I also answer that one, sir?
Let's go to another participant. There's a hand again. Is it still user? Let's go to
Yes,
Mama
I can.
Tebula. Can we go to Mama Tebula? Let's go to Mama Tebula. Right, Emma, can you hear me? Mama Tebula, can you hear me? Mama Tebula, can you hear me?
Hello, it's for my daughter. She just wake up. She's going to be joining you now.
Okay, no problem. No problem. Thank you very much. Now, in the meantime, let's go to Unkabetse. Unkabetse, please carry on with D.
Good morning, sir.
Morning, Unkabetse.
Sir, I calculated what's inside the bracket first, which was 10 plus 40.
Okay.
Which gave me 50.
All right.
And then I said 5 times. And then I said 5 times 50, which is 250.
Exactly. Exactly. So basically, that's what you do with a D. You have your bracket there, and of course, if X is 10, then you substitute for 10 there. 10 plus 40 is 50. And then you multiply by 5 to get 250. That is correct. Now we have to look at the last one, which is E 40 plus 5X. Let's go to the next participant. In this case, let's see. Let's go to Dante Adams.
Morning, sir.
Morning.
So I said 5 times X, which is 5 times 10, gave me 50, and then I said 50 plus 40 gave me 90.
I'm just
Okay.
You
So
just trying
basically,
to find out if it
can you repeat what you just said?
taken V.
I said 5 times 10. 5 times 10 gave me 50, and then 50 plus 40 gave me 90.
Okay. So 50 plus 40 gave you 90. So your final answer
Yes,
in
sir.
this case is 90. Yes, I fully
Yes, sir.
agree with you. Tanti, you are correct because if you multiply, if you multiply 5 by 10, you get 50. And then, of course, if you add the two, 40 and 50, you get 90. So that is correct. That is the correct expression there. So the final answer, of course, is 90. So basically, that is what you need to remember, that if you are given a word problem, you need to be able to express it in the form of, in mathematical form, like this case, what we started just this morning. In this case, for example, you have an expression, but the next one, you are told to subtract 5 from a number. And then you multiply the answer by 10 and multiply this answer by 3. So this is just a word problem, which requires that you understand how to subtract the number or subtract 5 from a number, and thereafter multiply the answer by 10 and multiply this answer by 3. So basically, this is what we have done. You subtracted the number, that number is y, and then you subtract 5, and of course you multiply everything by 10, thereafter multiply by 3. So we have evaluated these expressions as well, where we were able to substitute each value of x there. Now we are going to take our lesson to the next step, where we are going to learn a little bit about the coefficients, as I've indicated in the beginning of the lesson, but also the expressions, the different expressions. If you look at the first one here, we say that an expression with only one term, only, like 3x squared, we call this expression a monomial. That is what it's called. An expression with only one term, like 3x squared, is a monomial. That is one term because it is a product of 3 and x squared. So it forms, or it constitutes one term. And that is known as a monomial. Mono meaning one. And the second one, an expression with two terms, like 5x plus 4, is a binomial. It's a binomial because it has got two terms. That is what we mean by an expression which is called, which has got two terms. It's known as a binomial. And the word there, or the key word there being binomial, bi, which also means two. Different from bio, which means life. Bi meaning two, so there are two expressions there. The third one, there's an expression with 3 terms. You can see 3x squared plus 2x plus 9. We say that this expression is a trinomial. We call the expression a trinomial because it has 3 terms, and these terms are 3x squared plus 2x plus 9. So those are the expressions which I want to talk about this morning. I'm talking about the monomial, the binomial, and the trinomial. And of course, those are different expressions. The first one, monomial, has got only one term. And the second one, 2 terms, that's a binomial. An expression with 3 terms it's a trinomial. And what we say is that we use x to represent a variable. That is what we use. We use x to represent a variable. In the monomial 3x squared, the 3 is also known as a coefficient or coefficient. That is just a number next to the variable. We call it a coefficient. So if you look at 5x plus 4 and 3x squared plus 2x plus 9, the numbers 4 and 9 are called constants. Those numbers are called constants because it doesn't matter what you do to the expression. You can replace, you can substitute any value of x in those expressions, but the number 4 will always remain 4. Even in this expression here, 3x squared plus 2x plus 9, you can substitute any value of x, but the number 9 will not change. So any number that cannot change is called a constant because it is the same. It stays constant. So this number is not affected by the value of x. If x is 1, this 4 remains as it is. If x is 2, 4 remains. If x is 3, 4 also remains. If x is 100, it remains as 4. The only value that can change is the value of this expression here, 5x. It depends on the value of x. That will certainly change, but 4 will remain the same and 9 will equally remain the same. Therefore, they are called constants because they cannot change. Now, can we proceed to find a table which we are going to look at? In the table, I've given you the first example. As you can see, this is the table that we have. We have an expression, the type of expression, the symbol, which is used to represent the variable. We have the constant. We also have the coefficient of. Now, without any waste of time, you'll be able to see that when we look at this table, especially the first expression, in the first expression, you can see that we have got an expression x squared plus 6 plus 10. That is the expression that we have. And in the second column there, we want to ask what type of expression is this? We say that this trinomial. Why is it a trinomial? Because it has got only 3 terms. You can see x squared, 6x, and 10. So there are 3 terms. That is why we say the type of expression is a trinomial. Now the next column, what is the symbol used to represent the variable? You can see that the variables there are represented by the symbol x. So x is our variable in the expression. And the next question or the next column there find out what the constant is in the expression. So the number that cannot change in the expression is 10. That is the only constant that we have there. It doesn't depend on the value of x. It is just constant, meaning that no matter what you do to the value of x, that number will not change. 10 will stay the same. So it's a number that cannot change. It's constant. Now, the coefficient. What is the coefficient of the second term? The second term is 6x, as you can see. So this trinomial has 3 terms, 1, 2, 3. So the second term is 6x. So the coefficient of the second term is 6. That is the number that is found next to the variable. So that number is 6. I hope that you can see this coefficient that I'm talking about. So basically, in this table, we have worked out or we've filled in all the columns for the first expression. We have now found the type of expression. We've also found the symbol that is used to represent the variable. We also have the constant term there, and we also have the coefficient of the second term. So we have the coefficient of the second term. So now what I want you to do, or what I want us to do now, is to look at the remaining three expressions. There's an expression here, another expression, followed by the third one there. So basically, we have three expressions. And in this expression, I want you to tell me what type of this expression, what type of expression is this expression here? You need to give me the type. So anyone who is going to speak, or that user, your name is up. Can you tell us what type of expression?
Can you hear me, sir?
Yes, I can hear you.
I think it's a trinomial, sir.
It's a trinomial. Why do you say it's a trinomial?
Because it has three, what is this?
It has three terms.
Yes, sir, 3 terms.
Can you give me the terms? What is the first term?
6s squared.
Can you rephrase that?
6s squared, sir.
Okay, the second one?
S squared, sir.
Okay, the third one?
5, sir.
5. All right, the
Yes,
first
sir.
one, actually, it's 6s cubed. The exponent there is 3.
Oh, sorry, sir.
Yeah, so it will be 6s cubed plus
Oh,
s
yes.
squared plus 5. So
Yes,
yes,
sir.
I fully agree with you. I definitely agree with you. The type of expression is trinomial. The type of expression is trinomial. Now, do you want to perhaps tell us what symbol is used in the
It's
expression?
S, sir.
So S is the symbol that is used in the expression.
Yes, sir.
Constant?
The constant, sir, is 5, sir.
The constant is 5.
Yes,
the constant
sir.
is 5. Excuse me, the constant is 5 because this 5 can never change, even if the value of S can change. So the
Yes,
constant
sir.
is 5. Give me the coefficient of S squared.
Coefficient. It's I think there's no coefficient, sir.
There's no coefficient. Right?
Is it?
So thank you very much indeed. I don't agree with you when you say there's no coefficient. There is actually a coefficient.
It's 1, sir.
Okay, definitely. The coefficient is 1 because we usually don't write the 1. We know it's there next
sir.
to the expression there or next to the variable. So yes, the coefficient there will be 1. So thank you very much indeed, user there. Can we go to the next hand now? I see it's user again. There's only one hand up. Can I just go to Neo Galaxy J7 Neo? I don't know who is the owner there of the device. Like I said, like I always say, participation is compulsory. Even if your hand is not up, then I can just select you. Should we go back to Emma Matebula again? If you're out there, please tell me what will be the type of expression that is expression k over 3 plus 12. What type of expression is that? What type of an expression is that? Is it a monomial, trinomial, binomial? What type of an expression is that? Can we get the type of expression? Right, there are two hands. Kuto, your hand is up. Talk to me, Kuto.
It's a binomial
Binomial. Why do you say it's a binomial?
because it has two numbers and it's separated by a plus sign.
Exactly. So there are two terms. Basically,
Yeah.
there are two terms. Right? There are two terms. Now tell me what symbol is used to represent the variable?
K.
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 Exactly.
Yeah.
K is the symbol. Is there
Yeah.
any constant in the expression?
12.
12 is the constant, definitely.
Yeah.
Right. Now, the last one, give me the coefficient of the first term.
Is it 1?
Okay. What is, give me the first term. What is the first term there?
K over 3.
So it's K over 3.
Yes.
Now, what is the coefficient of K?
It is 1, right?
Okay. What about 3? What about the 3 in the denominator?
What about the 3?
Yes.
It's also 1, isn't it?
Okay. Now, okay, if you can check thoroughly, is it Kuto? Am I speaking to Kuto now?
Yes.
If you can check your expression, K over 3, basically this is a fraction.
Yes.
And this actually means this is a third of K. 1 over 3 means a third. And you multiply that by K. So basically, your coefficient will be a third, meaning that it will be 1 over 3. That entire 1 over 3 will be your coefficient. Because if you multiply that by K, you get K over 3. So your coefficient in this case will be 1 over 3. Does it make sense?
Yeah.
Exactly. Right. Let's go to the last one now. The last expression. I see there's few hands. I'm just going to identify one or two. All right. Let's go back to Unkabetsi.
Sir,
Yes, Unkabetsi, please proceed.
the type of expression is a monomial.
Monomial, okay.
The symbol used is P.
The symbol used is P, yes.
Sir, I think there's no constant.
There's no constant.
Yes.
Meaning that the constant is 0.
Yes, sir.
Okay, I agree with you.
And the coefficient of P to the power of 10 is 4.
Exactly. So the coefficient of P to the power 10, 4. So 4 is the coefficient. So basically, you have now concluded the the table by looking at the different expressions there, as well as the type of expressions, the symbol used, the constants, if there are any coefficients. So the last one, when we talk of the constant will be 0 because obviously we don't write the 0 there. It will be 4p to the power 10 plus 0. So the 0, even if it's not there, we know it's there all the time. You don't have to write it. So when it comes to the constant, you can say the constant is 0. But even if you say nothing, even if you say there is no constant, you are still fine because nothing means 0 means nothing. That is what it means. So you are correct when you say the constant there is 0. Now, this is what I wanted us to do in as far as the algebraic expressions are concerned. And this was just the beginning of algebraic expressions. the lesson that we just started in week 7, if you look at your annual teaching plan. And this was just the basic introduction to algebraic expressions. Remember what I said initially, that an expression, there are types of expressions. You'll have either a monomial, which has got one term, or you can have a binomial, which has got 2 terms. You can have a trinomial with 3 terms. So you need to understand this, the difference between the monomial, the binomial, and the trinomial, just like we did in our example here. And what is also important, you need to check your variables. X usually represents your variable. And in the monomial, 3x squared, 3 is called the coefficient. So the coefficient is always on the left-hand side of the variable. So there we are. You have 3 there as your coefficient. And if you look at the 2 expressions, 5x plus 4 and 3x squared plus 2x plus 9, you can tell that the 9 as well as the 4 constitute what we call constants. So I wanted you to be introduced, or just to introduce you to these different concepts this morning. And as we proceed throughout the week, we will build on the different algebraic expressions. You will have to, at some point, multiply the expressions. You'll have to multiply an expression with a monomial, with a binomial, with a trinomial. At times, you may also be expected to multiply the 2 binomials together, or a binomial by a trinomial, and so on and so forth. So we are still going to work with these algebraic expressions this week. But what is very important, you must remember how to classify your expressions. You must know that whenever an expression has got 1 term, it is known as a monomial, 2 terms, binomial, and 3 terms, trinomial. So that is where we will end our lesson this morning. And tomorrow, of course, we'll look at different roles that can be played by the expressions. But for your homework, or for your homework, you can visit our link here. This link is very helpful in as far as the introduction to algebraic expressions are concerned. And tomorrow, expand and simplify expressions. That is what we'll do tomorrow. We will expand and simplify. Again, this lesson was brought to you by the Lockdown eSchool in partnership with the Sasol Foundation. And of course, we are also found on social media pages. Visit us on Twitter account at Africa Teen Geeks. Also on Facebook, Africa Teen Geeks. You can also get the link, the Twitter link of the DBE at DBE_SA, as well as at MS Zora, one of our partners there. Thank you very much indeed for taking the time and the trouble to be part of this lesson this morning. Until we meet again tomorrow.
Sir?
Yes?
What do you call an expression with